Hi, this video will guide you through the process of installing certificates on your iOS XE router. Specifically, the certificates install process required to establish a TLS connection from your Cisco Unified Border Element, or Cube, router to the Microsoft phone system, also known as Microsoft Teams, for a direct routing configuration. However, the methods used in this video apply to most use cases where a user wants to install and configure certificates. In this guide, I will be using a Cisco ISR 4321 running iOS XE 17.2.1r. I'll show you two methods of installing the certificate on your router. The first method, we generate the key pair on the router and then generate the CSR on the router. The second method, we install a imported key pair certificate bundle. The first step is to generate the RSA key. So this is the command we need, crypto key generate RSA general keys, and we give it a label, so label, I'm calling it cube 0-key, and then modulus 2048, so it's 2048-bit key, and then exportable. Exportable is really useful because if you're paying for certificates, you don't want to have to generate a new key. The next step is to configure the trust points. The first trust point is the host trust point, so for the host certificate. The name of the trust point is completely up to the user. Enrollment terminal, this means we'll be pasting a base64 PEM formatted certificate in. At a minimum, you'll want the fully qualified domain name in the common name subject field. And the final command, RSA key pair cube 0-key, this is the key we just generated. So this key will be used to generate the certificate signing request. Wildcard certificates are supported. These can be defined in the common name or in a SAN record. The next step is to install our trust points for our CA certificates. The essential commands here are enrollment methods, so enrollment terminal, and revocation check. Our certificate provider actually has 4 certificates in the chain, so from root to host certificate there's 4 certificates, so we actually have to add 2 CAs to our router. This is not always the case, sometimes you just have to add 1 CA, depends on your certificate provider. The Baltimore trust point you can see here, this is so we can verify the certificate from Microsoft, so we need a trust point for that. Now you can have as many trust points for as many CAs on your router as required. They will only be utilized if they're needed. The next step is to generate the certificate signing request for the host certificate. Now to do this, we do crypto PKI enroll and then the trust point name of the host trust point. It will use the details that we put in earlier for the subject name, etc. And then we can display the certificate signing request in the terminal. So what we need to do here is copy this out and keep it safe. So this is a base64 PEM format certificate signing request, so we can just copy that out. We will then need to send that off to our provider, our certificate provider, so they can generate an SSL certificate for us. The next step is to add the certificates for our CA trust points. So what we need to do is paste these in. Now these CA certificates will be provided by the certificate authorities. This one is the Baltimore cert, so this is freely available online. So what we do is just copy that out, again, base64 PEM format, so we can paste that in. And as you can see, that's successful. And then we do crypto PKI authenticate for our other trust points. So here we paste in the certificates that were provided to us when we retrieved our SSL certificate from our provider. So they should send you all the certificates required in the chain, and we need to paste those into our trust points. So this one is the root certificate. This is the root CA. And then we do the same thing for our other certificate authority. This certificate sits just above the root CA, so it's an intermediate cert. And as I mentioned earlier, we have 2 intermediate certs in our chain. Now this next step, we do the crypto PKI authenticate command, but not for our CA. That's all complete. We do that for our host certificate. So what we need here is the intermediate certificate that sits just below the host certificate. This certificate is the one that verifies our host certificate. So crypto PKI authenticate, and then our host trust point name, so cube0 .cube-tme.com, and then we paste in the intermediate certificate. Now we can do crypto PKI import and then the trust point name, so cube0 .cube-tme.com, and then certificate. Now this certificate we're pasting in here is the top of the chain. This is the host certificate, and if this is successful, that means that the intermediate cert we just pasted in before has been able to authenticate this certificate. If you get anything other than a positive message after you pasted this in, then you've got something missing in your chain. So you haven't got the required certificates installed on the router. As you can see, this was all successful. So now I'd like to show you a few commands that allow you to verify that your keys and certificates are installed. So show crypto key mypub, and then ours is an RSA key, and then our key name will show you the key is actually configured. And then we do show crypto PKI trust points to see all of our trust points. We have our CA trust points, and we have our host trust point. And with the show run command, we can see the trust points and certificates in the running config. So this is useful to see if they actually are configured. And as you can see, for this host trust point, there was 2 portions to it. That means we've got the intermediate and the host certificate installed for that trust point. And the final command, show SIP-UA connections, TCP, TLS details. Now this is specific to Cube, but this will show us if our TLS connections are up, our TLS SIP trunks. So as you can see, we have 3 established TLS connections, which means our certificates are good. Microsoft is accepting these connections. So moving on to the second method of installing key pairs and certificates. This method, we import a PKCS12 format bundle. So that includes the key pair, it includes the host certificate, it includes the intermediate certificates. The reason you may want to do this is it may be a backup and restore from another Cisco IOS XE router, or you may have generated this bundle in OpenSSL on your computer. We're going to simulate a backup and restore of this trust point. So the first command we're going to do is crypto PKI export, the trust point name, PKCS12, and then the location where we want to export the PKCS12 file, and then a password to protect it. Our host and intermediate certificate that we want to import is already associated to an existing trust point which we created earlier. I'm going to put a no in front of that trust point, so no crypto PKI trust point name. That will delete that trust point, and it will also remove any certificates associated to it. So it will remove the intermediate and the host certificate. It will also disassociate the key from that trust point. Now we need to recreate that trust point. The enrollment PKCS12 method is actually there by default, so you don't need to enter that. And this is obviously different from enrollment terminal because we can't paste this certificate bundle in. So now that's created, we run the import command, crypto PKI import, and then the trust point name, PKCS12, and then the location of that PKCS12 file, and then the password we used to protect that file. And as you can see, that import was successful. Now we just need to verify that certificate key pair bundle that we imported to our trust point works. We can use any of the previously mentioned show commands. The one I'm using here is show SIP-UA connections TCP TLS detail, and as you can see, the TLS connections are up. For more documentation and guides on this topic, please go to cisco.com.